molecular structure and acid strength. So the strength of acid. Strength of acid depends on how easily the proton H plus ion is lost or removed. So the more polarized the bond between H and the atom to which it is bonded. So the more easily, if it is more polarized, then it's more easily the H plus ion is lost, or we can say it's donated. So if it is easily lost, then we can say that its strength is higher. Now we know that for binary acids, let's say for HX, binary acid, general formula is HX, right? So how do we determine the strength of this binary acid? So you can say that size of X in HX increases while we going down a group. Why? When we going down the group, the atomic size increases, right? If atomic size increases, then the molecule becomes larger, and if it is larger, it can easily remove H plus ion. So we can say acid strength increases. And for binary acid, when you're going across, so let's go to next page. For a binary acid, going across a period, as electronegativity increase, as the electronegativity increases, and you can say if electronegativity increase, acid strength increases. So with that rule you can say which one is stronger. Now I'm going to give you an example. Let's say which one is stronger. Which is a stronger acid? HF or HCl. So this is a binary acid, HF and HCl, like HX. We need to compare the size of F and Cl. When you compare the size of H and Cl, F and Cl, alright? So you can see fluorine, chlorine, bromine, iodine. When you going down, what happened? Exactly. The chlorine size is larger than fluorine, right? So if this is larger, then HCl, if this is larger, it can easily remove H ion, right, compared to HF, right? So which acid is stronger? HCl is the stronger one, stronger acid, right? So that way you can find strength of that acid. Now we are going to talk about another example. We need to find again which is a stronger acid. I'm going to write 1 H2O or H2S and 2 HCl or H2S. Alright, so now we need to compare the size of oxygen and sulfur. Now when you look at the periodic table, oxygen and sulfur, are they in the same period? Yes. But when you compare the size, now remember what was the rule we learned? Going down the group, size increase, and across a period, electronegativity increase. So when you go across, electronegativity increase, right? So compared to oxygen and sulfur, which one has a larger electronegativity, or which one is large? Yes. Sulfur, right? So you can see size of sulfur is large. So that's why H2S is strong acid. Okay. Now HCl and H2S. These are from the same period. HCl and H2S, they are same period, but different groups. Different groups. So we can compare electronegativity. Electronegativity, and we can say Cl is more electronegative than sulfur. So we can say HCl is stronger acid. So that way you can find strength of acid. Okay. Now we are going to work on oxyacids. Alright. So what is oxyacids? Let's go to next example. So for oxo acids, several factors are relevant. The number and bonding of oxygen. Bonding of oxygens. The central atom. And the charge on the species. So for oxo acids, I'm going to write general formula OHNYON. Now this is, let's say, general formula. Now you can see acid strength increase as an increase. So let's see, for example, I'm going to write OHCl, OHClO, OHClO2, OHClO3. Now in this case, remember, whenever N increases, acid strength increases. Now we need to check. When you compare those formulas, you can see N here is 0, N here is 1, N here is 2, and N here is 3. You see these numbers? That's the number. So when N increase, acid strength increase. So in this one, this is weakest, this is weakest, and this is strongest. So number of the oxygen increases, then what happened? Its acid strength increases. Now we said, okay, number and bonding of oxygens. That's the one that affects on strength. Now we are going to talk about the central atom and how it affects. This is the central atom and how it affects the acid strength. Okay? So, let's work on that one. Let's say we have HClO and HBrO. We have same numbers. The only thing, the central atom is different. Right? Now, how can we determine acid strength? We can say acid strength increases with electronegativity of Y. Y means central atom. Central atom. Central atom. So let's say I'm trying to draw this. Let's say this is oxygen chlorine and hydrogen, and this is oxygen, bromine and hydrogen. Okay. Now, this one delta plus and delta negative, delta plus, delta negative. When you compare electronegativity of chlorine and bromine, you can say this one is stronger and this is the weaker. These Y element we compare electronegativity, and that way we can say it's strong acid and weak acid. So that's how we determine strength of acids. Which ones are stronger